In this lecture, we are going to discuss about how to reduce state diagram states. Right. So we consider now we are having a state diagram. This is a state diagram SD. Now this is the given state diagram. Right. The state diagram is going to give now in that form. Right. So we are having state input out here A00. So state A by 00 it will go to A. So that is this edge, right? So its state is A, then a 0 input and 0 output, then it transit to A itself is the diagram, right? Next, we are having now that A 10. From the state A 10, it will go to state B. So we draw another new state, and then here this is we are having that edge, right? So then input 1, output is 0. Input 1, output is 0. Now we from the B, right? From B, we are having now that by 0 input, it will go to C, the output is 0. So here, input, output, then you transit to C, A, B, C, right? Then we are having C by input 1, it will transit to D, the output is 0. So that is here. 1, 0 input, output, it will transit to D, new state. Right. Then we are having now from the D. From D by 00, it will go to E state. So here you draw another state E, then by 00. By 00, we have to go for E. And then we are having E from this state E by input 1, output, then it will go to F state. So this is E to F. We are having a diagram. And then from F, we are having that input 1, 1. It will go to F itself. So if itself. So this is the case. So that is we are having now input 1, output 1. Then F by 0, 0, it will go to G state. So 0 input, 0 output. So that is this one. 0 input, 0 output. It will go to G state. Similarly, here we are having from the G by input 1, output is 1, then transit to F. So here from G, input 1, output 1, transit to F, this edge. And then from the F by 0, 0, it will transit to G. From here we are having now, from F by 0, 0, it will transit to already we are having now. Then from the F by 0, 0, it will go to G, right? Then here from G by 0, 0, it will go to A. 0, 0, it will go to A. Right? Now this is the transition diagram. Now this transition diagram can be reduced the number of states with that equivalent one. Right? Equivalent one means the whatever the transition is going to happen here, it will reduce the number of states and it will transit the required transition. Both are equivalent. Then how do you find out that one? Right? Now first you have to draw the from the state diagram, you have to write the state table. From the state diagram, you have to write the state table. So in the state table, what we are having now, that input is here, we are having 0 and 1, right? So input 0, 1. Then we are having, if you are having that 0, 1, then what's the output? Input, output, right? So that is, here we are having now from the state A. So start from A. A, from the state A, by input 0, it will go to state A itself. 0, it will go to A itself. At the same time, the output is 0. The output is 0. So here from A 0 0, what you are getting now from state A. From state A by input 1, input 0, it will go to A, the output is 0. Just you are getting. From the state A by input 1, by input 1, right? Input 1, the output is 0, then transit to B. The output is 0. Right? Like you have to fill all state edges you have to draw. right? So all state outgoing edges we have to draw now. Outgoing edges A. Then we are having B. So B you are having now C and D. So for 0 it will go to C, by 1 it will go to D. Then the output is 0, 0. So this is the case. Then you take C. From the C we are having now. So from the state C we are having now by 1 it will go to 0 to D. Then by 0 it will go to A. So here we are having C, D, right? So by 0 it will go to A, then this is C, right? So that is case. Then we are having that output is 0, 0 for 1, right? Similarly, you have to draw that D end, right? So like you have to consider all edges, then using the input output, then you are filling this table. Right. Now this is a table where we are having A to G is there. So A, B, C, D, E, F, G. Then the corresponding transition we have to fill that one. Now this is the table. From the table, now we are going to do some reduction. Here, now in that case, now you see this one. Here, A and F, right? So this is AF and this also AF, right? The transition also same. So E and G, in that one, you have to remove one state. You have to remove one state. See, these two are actually can be merged together. These two. And then we remove that G, right? So you remove that G and then wherever we are having G, we have to replace that one by E. So this is E. The G is replaced by E, right? Then you have to draw new table by reducing G. G is not there. Then for the F, we are having now EF. Now from the diagram, you see this one, the state table. You see E and F. E and F for all input. The transition is same for both cases as well as the output. Output also same. Then we can reduce from D and F can be merged and then the F is removed. Then wherever we are having that F, you replace this one by E. Replace this one by F, D, wherever E, D. So F and D, so you have to take representative as D, then you have to replace this one by D. Then we are having now another diagram. So we are reducing the one more state, right? So that F is removed, then D, wherever we are having that F, you replace that one by D, right? Now, this is the reduced table. Then for that reduced table, you have to reproduce the state diagram. So state diagram, in the state diagram, we are having A, B, C, D, E. Only 5 states. So A, B, C, D, E, and then transition, right? So you have to draw. So this is the state minimization technique. So how do you minimize the states, right? First, you have to draw using that value. You have to draw the state diagram. Then from the state diagram, you have to find out the state table. In that state table, so what are the possible edges can be merged together. Then for the two edges, if you are having that next state for all input and output for all input should be same. Then if it is same, then we can merge these two state and we have to take one as a representative. So that one as E and G is merged. Then you are having now the representative is E. Wherever G, you have to replace that one by E. Then next, if possible, we are reducing now. We have to see that one. These two states are same. And then we have to remove that one. So we are reducing that state, right? So here we are having 5 plus 3, 8 state. Here we are having now 6 states. 6, 5, 8 state, no, 1, 2, 3, 4, 5, 6, 7 state, right? So here we are having 7 state. 1, 2, 3, 4, 5, 6, 7 state. 7 state to 5 state. So here we are reducing one state, here another is reduced. So 5 states. Then this is the 5 state diagram. So this is a minimized state diagram. So suppose they may ask question, right? So how do you give the state minimization? Then you have to use these steps to reduce the number of states. Okay, we can stop here. We will continue by next lecture.